Okay, here we go. Section 5.3, Chapter 5. This is add, subtract, and multiply polynomials. Notice, by the way, that divide is not in the list. So divide will get its own section, and it's definitely the hardest of the four. Let's start with adding polynomials. And you have a choice. You can either add polynomials, what the book would like to refer to as vertically, or you can choose to add them horizontally, and it's really up to you. How do you prefer to do it? So here, here's a polynomial, a third order polynomial, leading coefficient +3, and another third order, and you'd like to add them. So the vertical method is just simply to write one above the other, and 3x to the third plus 1x to the third is 4x to the third. -2, -5 is -7x squared. There is no, if you have to write a placeholder, you could write 0x and then add those guys, and finally the constants. And so the other way is to do it horizontally, just to look at, one polynomial. Notice they use parentheses here just to distinguish, this is a polynomial, and then the other set of parentheses is, here's your second polynomial, and I'm going to add them together. And then you really just look for the like terms. Notice here there's no y to the third, so it stays. Your y squares are the 7 and the -4, so they group those guys together. Then you see there's a common y term. So it's just you really got to have good housekeeping, pay attention, and try to catch everything. Not hard, just be careful. And so the same applies for subtracting. So we can choose to subtract polynomials vertically, or we can choose to do it, right? Or, I like the word or here. You get to choose whatever is your preferred method. I'll never say you have to do one way or the other. So here they show you a vertical polynomial minus the second polynomial. Notice they do the subtract with parentheses. So you do want to distribute this negative into all four of the terms, right? The fourth, and then don't forget the negative to hit the 5. So you can see all the terms switch signs, and then then you're adding the polynomials. And so horizontally, again, same. Make sure you distribute. This feels a little bit like adding and subtracting complex numbers. At least it does to me. Again, that negative. This negative switches to positive. This negative switches to positive, and then you just add up the polynomials. Pretty straightforward. So why don't you hit pause here, see if you can't quickly take your time, but see if you can't subtract the two polynomials in problem 1 and add the two polynomials in problem 2. And again, your choice, vertical or horizontal. Here come the answers. And there are the two answers. Hopefully you got them right. If you didn't get part of it right, see if you can't find your mistake. It might just be a small mistake, or it could be something more important. Again, the distribution of the negative for problem 1 would be a big source of error if you didn't distribute correctly. And so finally, we would like to multiply the third part of the section, and we can do that either vertically or horizontally. So again, your choice, you decide, this would be an or. And so the first one here, you basically have, you take the 2, multiply each of the terms above, right? You get the 8, the -2x, and the 6x squared, and then you would do the same multiplication with the x goes to the 4 to the x. Sorry, it looks like I crossed it out, but it's again x times 4 is 4x, and you'd have to shift one place over, -x squared, and 3 to the x to the third. And then you just add up the columns, and you've got, your final answer. It's kind of a nice way. I actually like that one a lot. So this is probably the way you've done it more often than not. It's kind of distribution. The x here multiplies all 3 terms, and then the -3 multiplies in. You get this line here, and then you've got like terms, right? You've got the 2x squared parts and the 2x parts, and you combine, and you've got your final answer. So again, maybe in your homework tomorrow, we try both ways, and you decide which way you prefer, but you've got choices. When you multiply 3 binomials, and this happens quite a bit, these are, if you look at these are like factors. So if I was given a polynomial function in factored form and I wanted to go to standard form, I'd have to multiply this out, right? And again, when I say factored form, you would say if this was a polynomial function, the x-intercepts would be 3, -7, and -1. So anyways, got a little sidetracked. To multiply this out, typically most people will say, hey, let me take two factors at a time and multiply them out. So x minus 3 times x plus 7 would give you this quadratic. I'd multiply once more by the last factor, right? And the last example showed us how to do that. You'd multiply x into all three of these terms and then multiply 1 into all three, and then you've got a bunch of terms. You look to add like terms, and you've got your final answer. Again, powerful stuff. If this was a polynomial function in standard form, and I asked you to go backwards to intercept form, that's a lot harder, right? You've got to agree. But again, multiplying, this factored form into standard form, most of us are quite comfortable with that. Nice job. So you've got what the book refers to as special product patterns, and so I have to admit I'm not too big on these. I mean, I typically just I'm not going to memorize a ton of formulas. I find that difficult, and I typically forget them after a couple weeks. And then what does that do for me? So again, if you look at these examples, when I get y plus 4 quantity squared, I'm happy to just multiply it out. If you recognize this middle term is always 2ab, and this actually reminds us a bit about completing the square. We would always you could kind of feel how that was created. So you've got what we call the square of a binomial, right? It could be either a plus b or a minus b. And you also have the cube of a binomial, and again, these are neat patterns here to see this a to the third, a squared, a to the 1, a to the 0. And then b goes in the opposite direction, b to the third, b squared, b to the 1, b to the 0. And these coefficients of 3 here. Again, for me personally, if I don't memorize that formula, I can always just multiply this out, right? This is the same as x to the power, x plus 1, excuse me, times x plus 1, and finally x plus 1. So again, you guys, for me in this class and in the next quiz, maybe you write this formula out and you use it. You can't have a formula sheet on the mid-year, so are you going to memorize this? Probably not. We just multiply it out. It's a nice exercise. It's a nice way to go. With all that said, the difference of squares, again, this guy, recognizing, especially going backwards, is so important. So again, of these, I would, definitely focus in on this first one, how important that is. And so, the example now, example 5, again, the book's going to use its formulas. For me, I'm always happy to just multiply these out, right? These, this ends up being the difference of squares, right? And again, like I said, to recognize this guy and be able to factor backwards is pretty important. This course and other math courses that you'll take in years prior. And here, again, for me, I'd probably just square this out, but the formula says it's 2 times each of the terms, and then this to the third, is 3, excuse me, xy quantity squared. In the end, you need to get these final answers, and how you do that is going to be up to you. Hey, so you got a bunch of problems you can try here. Great multiplication. Just take your time, see if you can't come up with the correct answers. Those are coming in a second, so go ahead and hit pause. And here are the answers. I'm not going to walk you through all of them. It's kind of a lot of busy work. But if you got most of these answers, that's good. We'll practice more of this in class, and I will see you then.